Okay, good morning. Let's continue on our class on research methods. In the last three lectures, we talked about survey or survey research, right? So, survey is the first major quantitative research method um, that is a way of data collection, right? So, through survey, we can collect all kinds of data on people's attitudes, on their behavioral patterns, on their personalities, right, on their opinions, on socio-political issues, basically whatever that you're interested in, right? You can do that through survey research. And we said that with surveys, you can at least achieve three goals. The first is to describe patterns. By that we mean you can, based on survey research, claim that X% of individuals would support this issue, whereas Y% of the respondents would be against this issue, right? This is the first use of survey studies. The second goal that you can achieve with survey studies is you can establish correlations between two variables or more than two variables, right? Um, by measuring the predictors and outcome variables, you can make claims about, people's gender will predict their attitude toward, for example, legalizing marijuana use, or people's age will be associated with their, I don't know, level of extroversion, for example, right? So that is establishing correlations. And the third usefulness of survey studies is that when a survey study is properly designed and conducted, that is, if you can use stratified sampling and multi-stage cluster sampling to randomly select your respondents from your target population, then the results that you obtain based on your sample can be generalized to the target population. This is a very useful feature for survey studies and very valuable use of survey studies because our basic goal is to learn something about the target population, right? And for many reasons that we have discussed, a researcher typically cannot survey every single individual in the population, and therefore, uh, if the knowledge that we gain based on a sample can be generalized to the target population, this will be a very, very useful piece of information to obtain, right? So that's why survey studies are important and useful, and we spent three lectures to talk about. So starting today, we'll be talking about experiments. We'll spend 2 days or two lectures talking about experiments. And that is not because experiments are less important or useful than survey studies, but because experiments, the knowledge about experiments um, will quickly become very complicated, too complicated for the purpose of this class. So I sort of cherry picked, a few useful, knowledge points about experiments and sort of compress them into two lectures so as to give you a first view, so to speak, of this very complicated and very, very important research method. Okay? Because if you take more classes on methodology, you will know that experiment itself will be worth a whole semester's class time. Okay, so now we're going to talk about it in two lectures. So the content might be a little compressed and would involve a little bit of calculation. But as I said, yesterday, the most important point, for this class is that the calculation is very easy, but more important is to understand the reason behind the calculations. Okay, so let's make a start. So experiments is another quantitative research method, but compared to surveys, the single most important advantage of conducting experiments is that it can establish causality, right? So we typically talk about cause effect, right? Cause effect. So the goal of conducting experimental research is to study um, whether or not a hypothesized cause can indeed achieve the intended effects or the effects that we expect to happen, right? So that's the meaning of this sentence. As in survey studies, we need at least two variables to conduct an experiment because we'll use one variable to represent the presumed cause, and we'll use another variable to represent the intended effects. And we'll establish whether or not the cause, right, when it is made to happen, would indeed lead to the intended effects. So, okay, that will be our first variable, the variable that represents the presumed cause. And what we'll do as researchers to this variable is to manipulate it. By manipulation, we mean to artificially induce some change or difference in the variable, right? So here's a very critical difference. For example, between experiments and survey studies. So, for example, if we would like to study the relationship between time spent studying and GPA, right? So our hypothesis is very simple. That is, the more time you spend studying, the higher GPA you will get. Of course, we can study this correlation or this hypothesis by simply using a survey methodology. That is, we distribute a questionnaire around with one question asking participants about their time spent on study. For example, how many hours did you spend, studying yesterday or on a typical day, right? So people can provide a number, 2, 5, 10, 12, 24, etc., right? And then of course we'll have a second question on the questionnaire that assesses their GPA. We ask them, well, what is your GPA so far? 3.2, 2.4, 4.0, etc. And then we'll establish whether or not the time that they report in the survey will indeed correlate with the GPA that we report in the questionnaire. But if we're going to study this hypothesis, that is, more time spent studying will lead to higher GPA in an experiment, then we typically would not rely on self-report for at least the variable that represents the cause. So what we'll do instead of asking them to report how much time they spend studying, is we'll make them spend different time studying. So as a thought experiment, right, if this is possible at all in real life, we'll make one group of people study 10 hours a day, and then we'll make another group of people to study 5 hours a day. And then after, for example, a week, we'll compare their performance on a test and measure how the grade, right, they obtain from the test. So that is manipulation. In other words, we do not measure the presumed cause. Instead, we manually change the value of the variable that present the cause. For example, we make one value of the variable, time spent studying, 10 hours, and we make the value and we introduce a second value for the variable that represents the presumed cause, and that will be 5 hours. Right? We don't even give a chance for participants to report the amount of time they spend studying. Instead, we make them, spend this or that amount of time studying. So that is manipulation, right? It is through the effort of experiment, right, that we introduce some kind of a change in values, right, for the variable that represent the presumed cause. And of course, our goal by manipulating the variable representing the presumed cause is to see, well, whether or not we would observe the intended effects or the variable to be explained, right? So in this case, GPA, people's GPA, or people's difference in GPA is the variable to be explained, right? Because we ask ourselves why some people have higher GPA, why others have lower GPA. Well, this difference we hypothesize is because people spend different time studying, right? So GPA is the variable to be explained. And our hypothesis is that by making people, right, by manipulate the amount of time people spend studying, we'll be able to observe different GPAs, with the people who are made to study more hours obtaining higher GPA, and people who are made to study less hours obtaining lower GPA. Okay, so that's the idea of manipulation, and that's the idea of seeing whether the manipulation will result in the intended effects. Another very important point for conducting experiments is to make sure that other than the change that we purposefully introduce to the experiment, everything else should be kept the same across or between the different conditions, right? So here we have two conditions, right? We have two groups of people. One group of people are made to study 10 hours a day, and the second group of people are made to study 5 hours a day. But other than this difference, right? This is a difference. Other than this difference, all other aspects of the experiment will be the same. For example, the room that we put people into studying should be the same, right? Same temperature, same furniture, same kind of computer, same lighting, right? Anything that you can imagine about that room. And of course, the materials, for example, that we use to assess their performance, of course, must be the same, right? You can't make the materials easier or harder for one group than the material for the other group, right? That will also mess up the experiment. So it's important to keep in mind, right, that all other aspects of the experiment will be the same, except for the change or the manipulation that is purposefully introduced. Okay, so this is the definition of experiments, and this is an elaboration on sort of the definition, right? The key features that collectively constitute this method of that we call experiment. So let's sort of enhance our understanding of experiment by looking at another example. And this example starts with a very simple question, and that is how first impressions are formed, right? So this is a very simple question, but a question that has been studied by many researchers for many years. Because the basic idea is that people usually can make first impressions of total strangers very quickly and sometimes very accurately. But how do we do that? Okay, so probably the first study that kicked off this entire project is by Solomon Asch, right, a very famous American social psychologist. In 1956, Asch sort of reasoned or thought that maybe among the many dimensions along which we evaluate a person, how smart, how kind, how competent, how whatever, right? So these are dimensions along which we evaluate a person. And Ash sort of guessed or hypothesized that a basic dimension along which we evaluate a person, or a dimension based on which we form first impressions of another person, is the warm versus cold dimension, right? Or the person's interpersonal warmth, how warm this person is, right? To when he or she interacts with another person. And of course, given this hypothesis, the variable to be manipulated, or the variable that represents the presumed cause, will be warm versus cold, right? Because the variable to be explained here is, how do we make first impressions? How do we perceive a person, right? And we hypothesize that our perception of person will be caused by whether this person is perceived as warm or perceived as cold. So warm versus cold will be the variable that represents the presumed cause. And we want to see whether by manipulating this presumed cause, we can achieve the intended effect, that is, differences in first impression formation. Okay, so that leads to the idea that the variable to be manipulated will be a person's interpersonal warmth, right? Whether this person is warm or cold towards another person. And of course, the variable, as we just said, that is supposed to co-vary, right? To change along with the manipulation will be our perception of the person. More specifically, how friendly do we perceive this person, right? As a result of describing this person as warm or cold. So the experiment is very simple, and when we're describing the experiment, we're going to introduce to you the key concept that we use to describe experiments in general. And the first key concept or terminology for experiment is subjects. So subjects essentially are people who take part in experimental studies. So just as we have a sort of a name for people who take part in survey studies. By the way, they're called respondents, right? Just as we have a special name for people who take part in survey studies, we also have name for people who take part in experiments, and we'll call them subjects, or SS. And for some reason that may have to do with being politically correct, some people prefer to call these people participants. For the purpose of this class, I don't really care. You can use subjects, you can use SS, or you can use participants. They really mean the same thing, right? The same group of people. Okay. All right. So recall our experiments, right? So we're saying that by describing a person as warm or cold, we should be able to observe some differences in how others perceive this person in terms of the person's friendliness, right? How much a friend this person could be. So that suggests we at least need two conditions, right? A warm condition in which we describe a person as warm, and a cold condition in which we describe a person as cold. Okay? And then, of course, we'll keep all other elements of the experiment constant, and we shall see what this means in a minute with example. And then we ask them the same question: how friendly do you think this person is? Okay, so that will make a very basic design of an experiment. Okay, so more specifically, we can imagine that we have the first group of people come to a lab, and they're individually assessed, and then we told them, hey, well, there's a stranger that you're going to meet in a few minutes, and this person's name is Mike, and here are some words or adjectives that people use to describe Mike. And according to these people who know Mike, Mike is competent, skillful, industrious, warm, determined, practical, and cautious. Okay? But then we have a second group of people that we brought to the lab. Of course, this group of people would not talk to the first group of people, and then they will not, of course, read what the first group of people read. Instead, they will read the following, right? They were also told that you're going to meet Mike, very soon, and here's how people who know Mike describe Mike. So for group 2, they will read: Mike is competent, skillful, industrious, cold, determined, practical, and cautious. And to both groups of people or participants, they were asked how friendly Mike is, and they will presumably answer this question on a 7-point scale, right? 1 being not friendly at all, 7 being very friendly. Okay, done. This will be an experiment. 2 groups of people reading different materials, answering the same question, representing the variable to be explained, right? How do we perceive a person in terms of forming first impressions? And here we have or see a manipulation, right? And artificially induce the change in this case, describing a person's personality as warm or as cold. And we saw that other than this difference, everything else is the same, right? The name of this person, right, is spelled Mike, and all other descriptives or adjectives that were used to describe Mike are the same, right? The only difference is warm versus cold. Okay? So we call this variable, the perceived friendliness of Mike, the dependent variable, and we call the interpersonal warmth, right, the variable to be manipulated as warm or cold, independent variable. Okay, so this is not an independent variable. This is not an independent variable, but together, these two values that together constitute the independent variable that we call interpersonal warmth, because interpersonal warmth can take 2 values, warm or cold. Okay, so together they make a variable. This is the value of the variable, this is the second value of the variable, and as researchers we make the variable interpersonal warmth, right? Interpersonal warmth. We make this variable to take either this value or that value, and we see by taking different values whether this variable can lead to any change in the dependent variable, which is Mike's perceived friendliness. Okay, so let me repeat, this is a very important point. This is the variable that we intend to explain. But where's the variable that represents the presumed cause? Well, here we actually don't see the variable, but we sort of know by formulating the hypothesis that the variable that represents the presumed cause is called interpersonal warmth. But what we see here are the values, warm, cold, that this variable can take. And instead of measuring this variable as what we'll do in a survey study, we we manipulate this independent variable, right? The variable that represents the presumed cause, to make it take either this value or this value, and see by taking different values whether this variable will result in any changes, that is, the intended effects that we hoped to observe. Okay, so this is the idea of conducting an experiment. Okay, so we just said the variable to be explained we call dependent variable, or DV as a shorthand, and the variable that is manipulated and the variable that represents the presumed cause we call independent variable, or IV. So you might wonder why we're calling these variable these names. The reason is this. We call the variable to be explained the dependent variable because, as we just explained, its value, for example, how friendly we'll perceive Mike, will be dependent on the value that the independent variable in the personal warmth in our previous example would take, either warm or cold, right? Depending on whether in the personal warmth this variable takes the value of warm or takes the value of cold, the value of the dependent variable will change. That's why it is called a dependent variable. And we called the other variable, the variable that is to be manipulated, independent variable, because its value does not depend on this variable or any other variable in experiment, right? Because there's a causal relationship here. This the cause, this the effect. We say cause, effect, cause, effect. Of course, the effect depends on the cause, but the cause should not be dependent on the effect, right? So that's why we call this variable independent variable. Its value not being dependent on any other variables in the experiment. Okay? So in other words, dependence or independence really describes how these two variables are related, or their position or function in the hypothesis, right? Which is the cause, which is the effect. The effect will be represented by dependent variable, or DV. The cause will be represented by the independent variable, or IV. But of course, it would say, other than the manipulation, there could be many other reasons why we perceive a person as more or less friendly. Okay? Um, you know, it is possible, right? Some people are naturally overestimators. That is, these people, by their personality, tend to overperceive or overestimate a particular quality of a person, right? And you know, some, whereas other individuals are naturally underestimators. That is, they tend to overestimate a particular quality of the individual. So that is, regardless our manipulation, right? Anchor size here simply means, the value that we assign to different conditions. Some people would just, regardless the manipulation, some people will overestimate or overperceive the probability that Mike is more or less friendly. Okay? So the question, of course, is how do we rule out this possibility? How do we handle this critique? Imagining that this critique is from a colleague or a reviewer if you submit your paper for publication, right? That is, hey, other than your manipulation, there could be some other causes that results in the effects that you just observe. So you cannot confidently say that it is because of your manipulation that results in the effect. There could be alternative explanations, right? How do we handle this? The way that experiments sort of naturally handles this kinds of critique is by a process that we call randomization. Okay, so the beauty of randomization, which we'll define in a minute, is that you would reduce the influence of the personality effects of participants to as small as possible. Okay, so by randomization, we mean that we randomly allocate participant into either one of the conditions. In other words, every participant, they have an equal chance to be assigned to the warm condition or to be assigned to the cold condition. So before they take part in the actual experiment, before they're assigned to a condition, they don't know which condition they're assigned to because the probability is the same, right? In this case, you'll be half exactly, right? Half the time they will be assigned to the warm condition, but it's just equally possible that will be assigned, this person will be assigned to the cold condition. So this is called random assignment, right? So what random assignment can achieve is you can imagine that through this randomization process or random assignment, right? People of different personalities, overestimators, underestimators, extroverts or introverts, they will be equally likely be assigned to the two conditions, right? And another way to think about it is you have X amount of extroverts, Y amounts of introverts, and through this randomization process, between the two conditions, right, you will have roughly equal amount of extroverts and introverts, so that the personality traits would not be a factor that could confound our results. So this might sound a little bit abstract. That's okay. Let's make it more concrete. Okay. Again, let's end the slideshow. And what do we do? And let's create another empty slide or blank slide. Please hang on a second. Okay. Okay, here we go. So imagine, right, we have two conditions. This is condition 1, this is condition 2, and to stick to with our example experiment, this is the warm condition, this is the cold condition. Okay, and now we have a bunch of participants. This is our pool of participants, and our job, of course, is to randomly allocate this pool of participants to this group or this group. So let's say in this pool of participants, we have two types of people. There are extroverts, there are introverts, extroverts, 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 introverts, introverts, introverts. Okay, so we have 5 extroverts and 5 introverts. Well, to make, things easier, let's have an even number. So 6 extroverts, 6 introverts. So the idea is that extroverts, a characteristic of extroverts is these people are very outgoing and they're going to see anybody as friendly. Compared to introverts, they're a little bit shy and they're not going to perceive other people as friendly as extroverts will do. So, in other words, other than describing the target person as differentially being warm or cold, personality traits can also impact how participants perceive Mike as in terms of his friendliness. Okay, so let's first see what will happen if we don't do random assignment. That is, we put all individuals, right, in one condition. We put all extroverts in one condition, and we put all the introverts in a second condition. So yes, we must still see some difference as a result of the manipulation of warm versus cold. But you can quickly point out that, hey, Andrew, wait a minute. Any difference between these two groups might not be caused by your manipulation of interpersonal warmth, but because naturally these extroverted individuals will perceive anyone as more friendly than this group of people who are all introverts. And because of this, you're not certain whether the results or the effect that you observe is because of people's personality traits or because of the manipulation that you just introduced. So that's a big problem. Okay? To solve this problem, right, we need randomization. We rely on this process that we call random assignment to sort of reshuffle extroverts and introverts into these two groups. So one way to do that is to flip a coin, right? We say, well, heads will go to the warm condition and tail will go to the cold condition, right? The cold condition. And, the flipping coin will be a random process because you don't have control whether, well, that is unless you're practiced, right? So normally you don't have control whether you're going to get a head or tails, right? So get a heads, so this will go here. Turns out that the second time you flip a coin, you have a tail, so you get an introvert. Third time you have another tail, you get another introvert. But then for the next few times you have heads, and a tail. So you can see by repeating this process, right? And if our sample size, that is the pool of participants, are large enough, so eventually the two conditions in the end, if we follow closely the procedure of random assignment, will have roughly equal amount of extroverts and introverts in both conditions. And because the effects of these opposing personality traits will cancel each other out, right? So the effects of extroverts will be canceled by the introverts here, and the effect of extroverts will be canceled by the effect of introverts here. Then what is left will certainly be and must be the effect of the manipulation that we just introduced describing Mike as warm or cold. Okay, so this is the idea why randomization or random assignment is important. Okay, all right, let's resume our class. So now, after introducing the basic elements of experiments, we can start to answer this question, and that is, why can experiments establish causality? Because recall, at the very start of this class, we said that experiments, the distinguishing feature of experiments is that you can establish causality, which survey studies cannot do. Okay? But the question, of course, is why can experiments do that? To answer this question, we need to revisit the three criteria of causality. So if you recall from the first 1/3 of our class, the three criteria of establishing causality is that given our presumed causal relationship, A causes B, right? First of all, we must be able to establish that A is related to B, that is association. The second criterion is that for A to, for us to be able to claim that A causes B, we must be able to establish that A must occur prior to B. That is the requirement of temporality, because cause effect, cause effect, cause must always happen before effects takes place. The third criterion is there are no alternative explanations. That is, the presence of A must lead to the presence of B, and absence of A will lead to the absence of B. Because if there are other alternative explanations, then even if you take out or remove A, B might still be present because of confounds, right? So by ruling out confounds, we'll be able to confidently claim that it is indeed A causes B. In other words, if these are the three criteria of established causality, and if we say that experiments can establish causality, it follows that experiments are able to meet these three criteria. Okay, this must be the case because these are the logical requirements to establish causality, and if experiments are capable of establishing causality, then it must be the case that experiments can fulfill the three criteria. How is that so? Well, first of all, experiments can of course establish association because as we just said, right, an experiment needs at least two variables, an independent variable and a dependent variable. And with two variables, we can easily establish correlation. Okay? Temporality. Experiments are capable of establishing temporality because independent variables, the variables that represent the presumed cause, are always manipulated before we measure the dependent variables or the variables that represent the intended effects. And this is exactly why manipulation is such an essential feature in experiment, because if you simply ask people to report, for example, how many hours they spend studying, this report can actually come after they report a value for the DV, for example, their GPA. So in that case, GPA actually come first and the time they spend on studying come later. For example, a person might reason, well, I don't actually remember how much time I spent studying, but because if when I look at my transcript, I have a pretty good, GPA, that must mean I have spent lots of time studying. See, in this example, time spent studying actually come after the variable we tend to explain, and that certainly violates the requirement of temporality. So that's why we cannot rely on self-reports of independent variables to establish causality. We must manipulate the independent variable at the spot, right? We make people to study for different amounts of times. Then we measure their performance, academic performance, right? So studying for different amounts of time happens first, and then we measure their performance in a certain kind of test. So that way, we'll be able to make sure that indeed the cause, time spent studying, happens first and their performance follows. And this is the same for our example experiment based on ASH study, right? We have two groups of people read the description of Mike first, and then we have them estimate how friendly Mike is. So description of warm versus cold come first, followed by the perception of Mike in terms of his friendliness. So cause, the manipulation happens first and the effect happens later. And we just said, right, one way to establish causality and to rule out alternative explanations is through randomization. That is, we randomly assign individuals into different conditions. And we just demonstrated that, through a very simple thought experiment or exercise, right? By randomly assigned extroverts and introverts into the two conditions, over time and with large enough sample size, we'll be able to make sure that roughly the two conditions contain equal amounts of extroverts and introverts. And because each group has equal amounts of extroverts and introverts, the effect of personality traits, the effect of extroversion versus introversion, right, will cancel each other out. And therefore, this potential confound of personality traits will be ruled out, and that's ruling out one important source of confounds. So that's why randomization is important and helpful in establishing causality. But at the same time, in addition to random assignment, we need a second very critical aspect of the experiment to rule out confounds. And that second requirement is clean manipulation. What does it mean? Well, unfortunately, we don't really have a very good definition of clean manipulation, and in many cases, especially in social science, whether a manipulation is clean or not is a judgment call, right? So, if we recall the example experiment based on Ash's study, we will say that is a pretty clean experiment because we, describe Mike with, I think, 10 adjectives, and 9 adjectives are identical across two conditions, being competent, being industrious, being intelligent, etc., right? All those adjectives are the same across two conditions, and the only difference occurs between warm versus cold. So that's the only changing element. So that suggests it is pretty clean. In other words, we're not changing multiple elements with one procedure, with one manipulation. Okay? In other words, for a manipulation to be clean, one manipulation can only change one element. So with one manipulation, you can of course change the person description from Mike being warm to mic being cold, and you cannot do anything more. If you want to change other aspects of the description, you must uh, um, introduce a second manipulation, right? For example, this is our example, right? Competent, skillful, industrious, determined, practical, cautious, they're identical. The only difference is warm versus cold. So that is one manipulation, and this one manipulation results in one change. So that's good, right? In this case, the one procedure is person description. In this case, the one element that's being changed is interpersonal warmth. In one condition, this manipulated variable takes the value of warm, and in the second condition, this manipulated variable takes the value of cold. So that's clean manipulation. One procedure, one manipulation changes one condition. But let's imagine if in this experiment, and for the first group of participants, I present the following description. Mike is competent, skillful, industrious, warm, determined, practical, and cautious. And to the second group of participants, I describe Mike as incompetent, skillful, industrious, cold, determined, practical, and cautious. What is the problem? What is the problem? The problem, of course, you might have already guessed, is that the manipulation is not clean. Because with one manipulation, right, there's only two conditions here that suggest there must be only one change, right? We change from this condition to this condition, therefore only one manipulation here. And with this one procedure, we changed two aspects: warm versus cold, competent versus incompetent. Right? That's what we said. The manipulation of interpersonal warmth from warm to cold is confounded or is manipulated at the same time as the manipulation of how competent Mike is. Competent versus incompetent. Okay? So that way, any change in the perception of Mike could be due to the manipulation of Mike's warmth, or it could be due to the manipulation of Mike's competency. And because the two manipulations, the manipulation of warmth and the manipulation of competency, happens at the same time, would not be able to determine whether it is this manipulation or that manipulation or both manipulations results in any change in the perception of Mike's friendliness. We simply don't know. Okay? So that way, we're not be able to establish any kinds of causality because there are confounds. And the confounds is due to the manipulation of these two variables at the same time. Right? This variable because it takes the value of warm versus cold. This is also variable because it takes the value of competent versus incompetent. Once the two manipulations occurs at the same time, they confound each other and makes it impossible to determine which one causes the intended effect. Okay? So that simply suggests, for any experiment, we change one aspect at a time. We want a second manipulation, we want a second change, perform a second manipulation. We want a third change, perform a third manipulation. And that's the only way to establish causality, to rule out confounding variables or alternative explanations. Okay? So if an experiment is properly designed and properly performed, and therefore it is able to fulfill all three criteria of causality, we will say that this experiment is able to establish internal validity. And by internal validity, or the extent to which this experiment is internally valid, we mean the extent to which the claim of causality is warranted, right? Or the extent to which you can confidently claim that you are establishing what you try to establish, right? The causal relationship between, for example, time spent studying and GPA, or interpersonal warmth causing different perceptions of a person's friendliness. Okay, so this is internal validity. Okay, well, by the way, what is external validity? We talk about this concept when we introduced the method of survey. So just to refresh your memory, right? External validity means the extent to which, right, the same results can be generalized. The sample results based on your sample, can be generalized to your target population. That's what we mean when we say an experiment is externally valid. But if when you say the result warrants causality, you'll be saying that the study is internally valid. Okay? All right. Okay, so now after we sort of established the basic ideas of, or basic understanding of experiments, now we can start to talk about different types of experiments. So it turns out there are at least 3 types of experiments. There are between subject experiments, and under between subject designs, we have single factor between subject designs, and we have multiple factor between subject designs, factorial designs. We have between subject designs, that means we also have within subject designs. And once we combine between and within subject designs, we have mixed factorial designs. That is, as we said, combining between and within subject designs. So because of time and for the purpose of this introductory class, we'll not be talking about within or mixed designs. We'll only be focusing on between subjects designs that have 1 factor or 2 factors. Okay? So, in general, a between subject design or between subjects experiment is an experiment in which participants are assessed on the same dependent variable in separate conditions that they are randomly assigned to. In other words, different conditions contain different subjects. Right? More concretely, we create 2 conditions: warm, cold. Into warm condition, we put, let's say, 5 people. Into cold condition, we put 5 different people, or different 5 people, right? And then we compare if there's any difference between these 2 conditions. That's why it is called between subjects, right? Between these 5 subjects and these 5 subjects. Okay? So conditions in this sense, we can have a formal definition then, right? Conditions will then be the results, right, of a manipulation. And that is, by manipulating an independent variable, we will have at least 2 conditions, right? We make an independent variable to take 1 value, and we make the independent variable to take another value. As such, we have 2 conditions. But if we make an independent variable to take three values, then we'll have three conditions, right? That's what we say conditions, in other words, will be the values that an independent variable will take, or the levels of an independent variable. Okay, so in the previous example, right, the manipulation of interpersonal warmth results in two conditions. That is, a warm condition, a cold condition, right? In other words, the independent variable interpersonal warmth has two values or two levels. The first value, the first value or the first level of warmth is, I should say here actually as warm to make it more accessible, right? Not to use these unnecessary jargons. And a second condition or a second level will be cold. Okay, so as we said repeatedly before, warm is one value that the independent variable warmth will take, and cold will be a second value that the independent variable is made to take. So these are the two values of the independent variables. And now we also sometimes we also say these are two levels of the independent variable. So graphically, right, we can sort of represent this idea as follows. So we create through manipulation two conditions, two levels, right? And then we randomly assign some people into this condition, into this condition. And in both conditions, we have participants perceive the target person, results in two scores, right? These people in this condition provide scores which we can compute with which we can compute an average, and another group of people in this condition, right, will provide scores with which we can compute a second average, and later on we can compare if there's any difference between the two averages, right, produced from the two conditions. So we'll call this design a one factor between subject design with two conditions. The one factor here is interpersonal warmth, right? And it has two conditions because we make it take two values, warm, cold. It is between subject design because we assign different people into these two groups. In other words, respondent or participants in this condition will never be assigned to this condition, and vice versa, right? Participants in this condition will never be assigned to this condition. The participants in these two different conditions are totally different. So that's why it is between subject design. So that's why we call it a one factor interpersonal warmth. That's the factor, that's the independent variable, which has two conditions in a between subject design. So factor, as we say, right, in the context of experiments, is the same thing as independent variables or IVs. So we can use factors or IVs interchangeably. And of course, as we just said, right, we can, through manipulation, create more than two conditions out of one factor, right? So here we're still dealing with interpersonal warmth, but now we're saying, well, in addition to the two conditions, warm and cold, that we'll create, let's create another level, or let's make the variable, the factor, the independent variable, interpersonal warmth, take a third value, and we'll call it neutral. That is, we neither describe Mike as warm or cold, we simply remove the adjective while keeping all other adjectives and see how people will perceive Mike. So we'll call this the neutral condition, right? So in this case, we call it a one factor because all these three things are the values of the same factor in the personal warmth. It is between subject design because through randomization, different people are assigned to different conditions. And later on, we'll compare the differences between these participants who are assigned to these different conditions. And we have three conditions. So one factor in the personal warmth. Between subject design, different people are being assigned to different conditions, and they're compared against each other with one, two, three conditions. So just as a reminder, factor is the same thing as in the personal independent variable. We have one independent variable here with three conditions. That's why we call it a one factor design with three conditions. Right? So to reinforce our understanding or memory, conditions equal to the levels of the IV with three levels, three conditions. In this case, this independent variable or factor in the person warmth take three values: warm, neutral, cold. Okay. So with a single factor or one factor between subject design with two conditions, this is how we sort of tally the results, right? So we have our dependent variable here. So again, let me change the jargon used here from probability assessment to perception, right? Perception. So as we say, right, we will assign different people into these two conditions, which are the two values that the factor in the personal warmth would take. Let's say, we assign the first 10 participants into the warm condition, and on a 7-point scale, they indicate how friendly Mike is, with 7 being very friendly, 1 being not friendly. Okay, not 7 means very friendly. So as we expect, people are assigned to the warm condition, they score higher on the scale, meaning they're more likely to perceive Mike as warm. In contrast, and expected, people who are assigned, okay, so and then we can sort of calculate the averages using all these individual scores, and let's imagine the average is 5.5. Okay, so on average, they believe Mike as kind of warm, not very, but kind of warm, right? Higher than the midpoint 4. In contrast, the next 10 participants assigned to the cold condition also are provided with a scale, and expected because Mike is described as cold, they perceive Mike as less friendly. So their scores are sort of clustered toward this end of the scale. And let's imagine that they have an average of 3.5. So on average, these people, right, perceive Mike as not very friendly. And then we can easily plot the result. So again, I would change the name to, it's not anchor signs, but person perception, person description, or, interpersonal warmth, right? Interpersonal warmth, okay? And then the y-axis represents how friendly people perceive Mike is. And we know that people in the warm condition, right, they perceive Mike as pretty friendly compared to participants in the cold condition. Right, this bar is higher than this bar. If we make the graph better, we'll see some, reading here that says, this 5.5, the 3.5 in general or on average, people who believe that Mike is warm perceive Mike as more friendly than people who believe Mike is cold. Okay? So, this result will sort of suggest that our experiment is successful. And in general, we'll call an experiment successful if the manipulation, here the manipulation of cold, warm, the manipulation of interpersonal warmth, produces the difference in the intended direction across the two conditions. We have two conditions here, and as expected, right, we observe that people in this condition have higher scores on perceived friendliness of Mike than participants in this condition. That is, the difference in the intended direction between these two conditions. And then we can conclude, aha, this experiment is successful. The manipulation of interpersonal warmth works. Okay? So, in other words, the essence of analyzing experiment is to compare averages or means, right? Averages, means across different conditions. And that's especially true for between subjects experiments. Okay? Okay, so far we've discussed experiments which only has one independent variable. For example, interpersonal warmth, right? We can, through manipulation, create multiple conditions. We can create multiple conditions from this one or single independent variable. We can have two, we can have three, we can have four and five, doesn't matter. Okay? But now the question is, we can create multiple conditions from one factor or from one independent variable. But now the question is, what if we have more than one factors? We have multiple independent variables, and from each independent variable, we can create multiple conditions. How do we analyze experiments like that? Multiple IVs, multiple conditions under each IVs. What do we do with those experiments? All right? So that will be the content for our next class. All right? So, see you tomorrow.